to Unit 1, Section 5 of AP Chem, Density and Energy. I know I'm excited to be here. I know you're probably not excited to be here because you're probably a chem student and I am so sorry. But let's talk about density and energy. First of all, to talk about density, we need to have a quick refresher. Density is an example of a derived unit of measurement, meaning it is obtained from one or more of the SI base units or from another derived unit. And in density's case, it's derived by dividing mass over volume. And as a quick refresher, mass is the amount of stuff in an object, and it's measured in kilograms. And volume is the amount of space an object takes up, and it's measured in meters cubed. So density is defined as the amount of mass in a unit volume of a substance, and it's found by dividing mass over volume. However, against logic, density is not measured in kilograms over meters cubed. Instead, it's measured typically in grams over centimeters cubed or grams over milliliters. This is because mass was originally described as the mass of 1 milliliter of water at a certain temperature. Because temperature matters, guys. The density of water below freezing is completely different from the density of water at room temperature and is completely different from the density of water above boiling. There are 3 different states of matter, but I digress. So, because we understand that density is mass divided by volume, let's take a look at a problem. So this is our second density equation, and it says, a cube has a mass of 12.01 grams. If the cube's density is 10.23 grams per cubic centimeter, what is the volume of the cube? Now here we have our very lovely drawn cube, and over here we have the equation for density, which is mass divided by volume. And what I did is I plugged in our known values in the equation. So we know that the density is 10.23 grams per centimeter cubed, and we know that the mass is 12.01 grams. And what we don't know is the volume. And so if you switch this equation up, so we have volume on its own side, we get 12.01 grams over 10.23 grams per centimeters cubed. The grams cancel, and we end up getting 1.174 centimeters cubed. This is our final density problem. It says a cube has a volume of 8.12 centimeters cubed. If the cube's mass is 12.08 grams, what is the density of the cube? Now just remember, with the handy dandy cube drawing, that means absolutely nothing. And the density equation, density equals mass over volume, you should be able to do this easy peasy, and I will have the answer in just a second. So there is the answer, 1.487 grams per cubic centimeter. Don't forget those units. Hope you got the right answer. You just plug it in, you divide 12.08 divided by 8.12, following mass divided by volume, and that's your answer. On to energy. So the energy SI base unit is a joule, which is based on this fancy equation that I'm not going to even try to say nor understand, but essentially energy is based off the movement of particles, and that's what joules measure. And if you can extend your imagination, if a joule measures the energy of a single particle, it's a really small amount of energy. So in day-to-day use, we typically use kilojoules. And when I say day-to-day use, we really don't. That's really just scientists. Us, like the regular old people, with the snazzy goggles, we typically use calories, and not the calories that necessarily the scientists sometimes use. The whole thing's kind of ridiculous. There's joules, which is like the formal stuff, and then there's all the different calories. There's calories with a little c. Calories with a little c equals 4.184 joules exactly. Then you have the calories with the big C. It's 1,000 of the little ones. And that, the big C ones, is how we measure how much energy we get from our food. And then that big C is also equal to a kcal, which is equal to 1,000 of the small ones. So 1,000 of the small ones get you both a big C and a kcal. And the only differentiation is a couple of letters, all that make the K sound, and sometimes they're capitalized, sometimes they're not. It's a very American system to me. Like, it sounds like an American created it. But either way, here's the table somewhere, I'll put it somewhere, of the equivalencies. And now that we know those, let's move on to a few problems. This is our first energy question. It says, 9 kilograms of propane reacted completely with oxygen. For every gram of propane that is produced this way, 46 kilojoules are released. How much energy was produced in joules? That's a question. So our first step after fixing grammatical errors is that we want to convert that 9 kilograms to grams. And so we use the conversion factor of 1 kilogram equals 1,000 grams. Then we want to work on the next part that we were given in the question, which was for every gram of propane that is produced, we were given 46 kilojoules of energy. So for every gram, 46 kilojoules of energy. However, we're not asked for kilojoules, we're asked for joules. So we have to use our final conversion factor of 1 kilojoule equals 1,000 joules. Then once that is all done, we multiply right across. 9 times 1,000 times 46 times 1,000, which gives us 4.1 times 10 to the 8th. And how we know it's joules is we look at each and every single one of these units and how they canceled each other out, except for joules, which means we properly answered the question by matching up the units, and assumingly you typed your numbers correctly into the calculator, you also got the number half of it right. So yeah, that's how you solve this problem. So this is our final energy problem. It says a 12-ounce vanilla milkshake contains 547 calories. What quantity of energy is this in joules? So here are your conversion factors of all different types of measurements of energy, and I will be right back with the answer. So here is the answer to the last problem. 2.29 times 10 to the 6 joules. You just use your conversion factors. You take the 547 nutritional calories, you use the conversion factor from nutritional calories to regular calories, and the conversion factor from regular calories to joules. You cancel out your units, you multiply across, and that's what you get. Easy peasy. So that's the end of my chem talk about density and energy. Hope you all had a absolute blast learning chem. I know I absolutely blasted off my top a couple times filming this. Once I kicked my crutch, I lost the fight. But you know, thank you for coming along for the ride. Enjoy your chem journey.